Thank you for joining Pioneer. I'm Chris with Norman Public Library Central, and this is the next video in our series on the Swift computer programming language. In our previous video, we learned how to use the JSON serialization object to begin interpreting the information we've gotten back from the National Weather Service. In the challenge I left you with, you were supposed to take your own information that contained the forecast and translate it back into an object for the computer to parse. Here's my solution to that challenge. Most of the code here is the same that we've seen before. The only change was that instead of simply printing out our weather response, I'm now decoding it using the JSON serialization object. Remember that I have to convert my string into a data type object, and I used a UTF-8 encoding to do that. I passed an empty array as my options, and finally I simply printed out my decoded information. When you print your decoded information, you'll be able to see the forecast, but you'll note that it looks almost exactly the same as what we saw before. Today, I'd like to change that by learning about dictionaries. You can download the starter code from Pioneer Library System's website at this URL. Don't forget to update your main.swift file to try running Lesson 15, Dictionaries. Right now, when we print out decoded, we see a JSON object. Let's take a closer look at that JSON object now. Inside our JSON response, we see an open curly brace, and then we see a set of double quotes and some kind of word inside the double quotes, followed by a colon, followed by a bunch of stuff. This object is called a dictionary. It takes one word and uses it to look up something else, just like a dictionary in real life. In real life, a dictionary is a book where you look up one word and it gives you the definition or definitions of that word. That means that based on one word, you can get multiple pieces of information about that word. In a computer, a dictionary works just like that, but it's a little bit more general. Let's create a couple of simple dictionaries. I'll create a dictionary full of words and their definitions. For example, I could say that my dictionary is equal to, and we'll use an open square bracket, just like we did to create an array. And then I'll say I'm going to look up the word awesome. Now is where a dictionary becomes different from an array. I'll put a colon after my double quoted word, and now we put the definition of awesome. For example, Chris Hennis. We can add multiple items to our dictionary. For example, we could add the word boring. And after the word boring, we could put Aaron Pence, my boss. True story.
Hey!
Now, if I print line 42 will print my name. It looked up the word awesome and saw that the information associated with it was Chris Hennis. So when I print my dictionary awesome, it prints Chris Hennis. You'll see a warning from Swift. The expression is implicitly coercing from string question mark to any. It's important to note that your dictionary might not contain a definition for the word that you're trying to look up. Even though I am fantastic, if I try to look up fantastic in the dictionary, this response will give me nil. In a computer, a dictionary doesn't have to go from a word to a sentence. In fact, in a computer, you can make a dictionary from just about anything to just about anything else. For example, I can tell Swift that I would like to map from a string to an integer. And into that dictionary, maybe I'll put a question. And its answer, which is an integer. So I can look up an integer based on a string. If we look at our JSON response, We can look up a string, context, and it's delivering to us an array, for example. Or if I scroll down through, I can see that if I look up the string properties, it delivers to me another dictionary. So in this case, I have a dictionary within a dictionary. Let's see how that works in Swift. I'll delete the extra code that we've added. And now, instead of simply printing out decoded, let's convert it into a dictionary. I'm going to use a guard statement because it's possible for this type of conversion to fail. And I'll use the as keyword to convert from whatever a decoded object is into a dictionary that maps from a string to anything. And remember that because I've used a guard statement, I have to say else, and if this statement fails, we'll just exit our code. Now I've converted whatever type of object decoded is into a dictionary that maps from a string to any other data type. Next, let's look up the properties in our string and map it to another dictionary. Finally, let's investigate which property we need to look up. If we re-examine our JSON, we can see that we have properties for forecast office, grid X, and grid Y, but we can see that we also have a property for the forecast itself, which is a string that gives us the URL that we ultimately need to ask for our forecast. So finally, we'll extract the forecast property from our forecast. And this time, remember, it's no longer a dictionary. It's just a simple string. Finally, let's print out our forecast string to see where we're supposed to be going. I'll run my code. And I'll see that I can get my forecast from this URL right here, exactly the URL that we had been hand constructing earlier. Your next challenge is a tough one. I'd like to see if you can take what we've learned about dictionaries and parse the JSON dictionary you get back from this forecast URL. I will warn you, however, not everything in there is either a string or a dictionary. One of the objects is actually an array. So as you are going through the casting process and stepping through your JSON, keep your eyes open for the array object. Don't worry if you can't get it. I'll give you my answer next time. Good luck.